To model with polynomial functions, we're going to write the polynomial function that's represented by this set of numbers. In order to do that, we first need to figure out what kind of polynomial we're working with. If we make a quick sketch of this set of numbers, when x is 1, f of x, our output is 6. When x is 2, our output is 15. When x is 3, our output is 22. When x is 4, our output is 21. 5, we get 6. And 6, we have negative 29. So somehow our polynomial has to hit all of these points. The question is, what kind of polynomial are we working with? Do we have a linear polynomial? Is it a quadratic polynomial? Is it a cubic polynomial? Are we seeing just part of the cubic polynomial? Or is it quartic? Are we seeing just a part of the quartic polynomial? So we need to figure out what kind of polynomial we're working with. To do that, we're going to look at the finite differences. To figure out the finite differences, we need to make sure that our numbers in the x column go in order. 1, 2, 3, 4, 5, 6. And then we take our outputs and we subtract them. So I'm going to take 15 minus 6. And then 22 minus 15. And then 21 minus 22. Make sure that you take this number minus this number. I should get a negative 1 right here. 6 minus 21 gives me negative 15. And then I need to make sure that I take negative 29 minus 6. And that's going to give me negative 35. So I found the first order differences. I've subtracted one time. If all of these numbers across here were constant, if they were all the same, I'd be working with a linear polynomial. These numbers are different. They're not all the same, so my polynomial is greater than a linear polynomial, which we can kind of see from our graph. This is definitely not going to be a line. So let's go to our second order difference. So I'm going to subtract again. 7 minus 9. Make sure I take this number minus this number. Negative 1 minus 7. Negative 15 minus negative 1. I'm subtracting a negative 1, which is going to give me negative 15 plus 1. And then negative 35 minus negative 15, which is negative 35 plus 15. This was my second order difference because I've subtracted 1 2 times. If these numbers were constant all the way across, if this was the same number over and over again, I would have a quadratic polynomial. So this polynomial is not linear and it's not quadratic. This is not part of a polynomial. So I need to keep going. Negative 8 minus negative 2 gives me negative 6. Negative 14 minus negative 8 gives me negative 6. Negative 20 minus negative 14 gives me negative 6. This was the third order difference. Notice that I'm constant all the way across. Negative 6, negative 6, negative 6. These are all the same numbers. So my polynomial will be cubic. Whatever order difference is constant, that's going to tell me what kind of polynomial I'm working with. So this polynomial is actually part of a cubic graph. Next step. Now that I know that I'm working with a cubic polynomial, I need to write the formula for a cubic polynomial in standard form. F of x equals a number times x cubed plus a number times x squared plus a number times x plus a constant. So ultimately, I want my formula, my equation, to look like this. And I need to figure out my a and my b and my c and my d. To figure out those numbers, I'm going to plug in some values that I already know. I know that when x is 1, f of x is 6. So if I plug in 1 for x, my output, my answer, my f of x, is going to be 6. f of 1 is 6. So I'm going to plug in 1 for x. And if I plug in 1 for x, I know that my answer has to be 6. Now I need to simplify. 1 cubed is 1. 1 times a is just a. 1 squared is 1. Times b is b. C times 1 is c. And d is just d. So I have my first equation. If you notice, I have 1, 2, 3, 4 variables that I'm solving for. I'm going to actually set up a system of equations to solve for these 4 variables. Since I have 4 variables to solve for, I need to set up 4 equations. In order to solve for all 4, I need 4 different equations to work with, so I'm going to move on to the next point that I know. When x is 2, y is 15. So I'm going to plug in 2 for x. So I have a times 2 cubed plus b times 2 squared plus c times 2 plus d. And when x is 2, my output is 15. So I'm going to simplify. 2 cubed is 8. 2 squared is 4. c times 2 is 2c. Plus d equals 15. There's my second equation in my system of equations. I need to keep going. I'm going to move to my next point. When x is 3, my output is 22. So I'm going to plug in 3 for x. So I have a times 3 cubed plus b times 3 squared plus c times 3 plus d, and my output will be 22. So I have 27a plus 9b plus 3c plus d equals 22. I still need a fourth equation since I have 4 variables, I have 4 unknowns, so I'm going to move on to my next ordered pair. When x is 4, my output will be 21. So 4 cubed is 64 plus 16b plus 4c plus d equals 21. So I have 4 unknowns, a, b, c, and d, and I have 4 equations. So I have my system of equations set up. I can solve that system of equations using substitution or linear combination or even Cramer's rule. If I wanted to, I could set up 4 different variables, a constant matrix, and then 4 different matrices for a, b, c, and d, and then solve for those matrices using Cramer's rule. But I'm going to show you another method using your calculator to solve this system of equations. To do that, I'm going to make an augmented matrix. To make an augmented matrix, I'm going to make the matrix 4 with 4 rows across. So it's going to be a 4 by, and then I'm going to make a column for all my a's, a column for all my B's, a column for all my C's, a column for all my D's, and a column for all my answers. So this is going to be a 4 by 5 augmented matrix. So my first row will be my first equation, but it's going to be the coefficients of all my variables with my answer. So it's going to be 1, 1, 1, 1, A, B, C, D, and then my answers. And then my second column is going to be my second equation. A, B, C, D, my answers. Third row, third column. A, B, C, D, and my answers. And my last row is going to be A, B, C, D, and my answers. So I have an augmented matrix where each row is my equations. Now my calculator can solve this system using what is called the row reduced echelon form. To use the row reduced echelon form, enter this matrix into your matrix editor. So I need a 4 by 5 matrix. And my first row is going to be 1, 1, 1, 1, 6. Enter in my second row. Enter in my third row. And finally enter in my fourth row. Now I need to quit back to the home screen. If I just go to my matrix and I just show matrix A, this matrix should be this matrix. Now to do the row reduced echelon form, I want to put matrix A on the home screen, go back to my matrix menu, scroll over to math, and then if I hit the up arrow, I'm going to go to the bottom of this list. And if I look right here under B is my RREF. So I want to do the RREF of matrix A. Make sure that you pick the RREF and not the REF. This is something different. So I want to do the row reduced echelon form of matrix A. And I accidentally have an extra matrix A right here, so I'm going to delete that out of there. So I want to do row reduced echelon form of matrix A. And then hit enter. And what I'm left with is a 4 by 5 matrix that looks like this. Now you should recognize the left part of this matrix. The left part of this matrix is the identity matrix. And if you remember, this column was my A column, and this column was my B, and this was my C, and this was my D. So when I have one A and no other variables, my answer is -1. So 1A equals -1. 1A is just A equals -1. And when I have 1b and no other variables, 1b equals 5. And 1c equals 1. And 1d equals 1. So my calculator solved this system of equations using the row reduced echelon form. Now I need to write the equation of my answer. I know A, B, C, and D, so I'm going to write my equation in function notation. F of x equals negative 1 x cubed, so negative x cubed, plus 5 x squareds plus 1x plus 1 constant. So this is the equation of my function. I can always check that answer by graphing this equation. Negative x cubed plus 5x squared plus x plus 1. Go to Zoom Standard. And let's test our points. I can hit the trace button, and when x is 1, I should get an output of 6. When x is 2, I should get 15. When x is 3, 22. When x is 4, 21. 5, 6, and 6, negative 29. So I know that this is the correct answer. It hits all of my ordered pairs.